So they're kind of obvious responses that we see. But in order to be able to satisfy ourselves that those are typical responses, that we can be certain they are appropriate responses and that they're not artifacts of noise, we need to be certain about the validity and reliability of the ECG signal that we're recording. To that end, one of the things that is fundamental to this is the placement of those electrodes that we're referring to, in other words, generating the 12-lead ECG trace using your 10 electrodes. Now, this is from a really neat study that was published not that long ago, and it was looking at accuracy in ECG lead placement amongst technicians. So these are experienced people, nurses, general physicians, and cardiologists. And so what you can see is the way in which they placed V1, V2, V3, and V4 across a population within an individual, and you can see the way that these were spread. But what you can see is there is quite a spread, and this is for all of those population group at the moment, all of our trained individuals. But can you see that there's an awful lot of disagreement? They're not all in the same place. Now, bearing that in mind, and bearing in mind that the heart of this individual they did this on, this case study they did this on, won't have moved, you can automatically understand that depending on where those electrodes are placed, you're going to get very different ECG responses. So what does this really look like? Well, if you look here, we've got a comparison between nurses and cardiologists. So this is the lead placement. Again, this is V1 to V4, and you can see the nurses on the left, and you can see the cardiologists on the right. So what the shapes refer to is they refer to the standard deviation. It's plus or minus 2 standard deviation of the mean, so it's the spread. If you look for the thin lines, they actually represent where the cardiac technicians, the experts, are placing the leads. Can you see? Look at the difference. You can see that the cardiac technicians know where the leads have got to be placed. You can see V1, you can see it goes through the right between the two of the intercostals. You can see the same for V2. But can you see how there's a big difference between these two groups who aren't meant to be experienced? I mean, nurses are less experienced than cardiologists. Nurses are not, by any means trained in this. But cardiologists, who are in essence kind of the surgeons, are not as well adept at this as the cardiac technicians, whose only job is to work within this field. But you can see there's an awful lot of distribution in terms of the placement, which is going to have a significant ramification on the reliability of the signal that we induce. And the problem is that signal is what's being used to make your diagnosis of what is happening in that individual's heart. So actually, how does this manifest itself? Well, here you've got and they're taking in the example just lead V1, and you can see the V1, the proportion of V1 electrodes in the fourth intercostal space. That's the correct space. So in this example, here's the cardiac technicians. It's about 90% got it absolutely spot on. The nurses, about 50%. Non-cardiologist physicians, about 30%, and the cardiologists, it was less than 20%. So there are two take-home messages, I suppose. One is, be slightly worried if your ECG is being done by a cardiologist. But secondly, that it shows how you have to be trained. These cardiac technicians are experts in ECGs. And it shows that individuals, even individuals who have got a fairly good idea of where the leads can go, are not going to be able to place them as accurately as somebody who's highly trained. And therefore, the reliability of the signal that we get from, in this case, our nurses, non-specialists, and the cardiologists, the reliability of that signal is well, as an example, is probably for our nurses 50%, has got probably a variation of about 50% compared to what we see in our cardiac technicians. It's probably got about an 80% variation from our cardiologists compared to our cardiac technicians. So in other words, there's significantly more chance of error for the cardiologists, the non-cardiologist physicians and nurses compared to the cardiac technicians. So you have to be highly trained in order to be able to satisfy yourself that the signal that's being produced is suitable to make appropriate determinations. And again, we can see that here. So here we can see proportions of measurements in the horizontal, which is our lower table, and vertical plane. And what they are, these are ones that have got greater than a 35mm displacement between trained observers. Greater than 35mm. And look at this, you can see where the displacement is occurring. So if you look, the biggest difference is on V5. There's about a 40% difference, quite significant range in women, and about a 36% range in men. So in other words, when you're testing males and females, and of course you can understand why there are differences between getting those electrodes placed between males and females, and why there might be greater variance in females than males, because of the fact that we've got the mammary glands which are in the way, and therefore makes it much harder to be able to identify those key regions. It is much harder to collect these in females. So again, you can understand how our signal now starts to become so fundamentally determined by the accuracy of the placement of those electrodes.